This asks us to evaluate this indefinite integral, the integral secant tangent plus cosecant squared, all with respect to x and all with arguments x. Let's go ahead and do that. In this case, again, it's fairly straightforward. Secant tangent has an antiderivative of secant of x. Secant x times tangent x has an antiderivative of secant, because if you take the derivative of secant of x, you get secant of x times tangent of x. An antiderivative of cosecant squared. Well, if you remember, the derivative of cotangent is negative cosecant squared. So the antiderivative of cosecant squared of x is going to be negative cotangent of x. That's one antiderivative. If I want all of the antiderivatives, I simply need to add a plus c at the very end. Including an arbitrary value for c allows us to classify all antiderivatives of secant x tangent x plus cosecant squared x. This is your final answer. Before I move on, I want to just point out a few things. The first is we did a lot of examples on finding antiderivatives or finding the indefinite integral. These things are things you should have down pat. Just like your rules for taking derivatives, you want your rules for integration to be very easily recalled. We're going to use these over and over and over again in chapter 5, and we're going to use these a lot if you get into the next class. So these are rules that you'll want to know moving forward and have down pat. So make sure you're doing lots and lots of examples of integrating various functions.